Okay, so as I mentioned, in Chem, you can run but you cannot hide from Stoic. Here in Math Theory 1, you can run but you cannot hide from transformation. Guess what we're going to do? Transformation again. Yay! So if you look at this, for some of you, this is good news. Why? You got what's going on already. There's nothing really new except that for the function we talk about here, the function we talk about, instead of just a random function, polynomial function, rational function, it is log function. Okay, so there's nothing really new here. Let me just jot down that here from your formula sheet. So the general formula is y equals a times any function, and then b, make sure you take b out of x so that x is by itself, and then k. Okay, same idea. Have a look. Function is now the log, maybe something other than base of 10, but look at that. Same idea. For others, this is your nightmare again. The only difference, or the only thing you need to be aware of, is that whatever inside here, it must be positive. Remember, in previous lesson we talked about that you cannot take the log of 0. That's undefined, that's error. You cannot take the log of a negative number, that's undefined error. And also in our previous discussion, when we first talked about logarithm or even exponents, that these two b are the same thing. This is the base, log base 2, log base 10. This b, same notation, but it means the horizontal stretch factor. Right? So let's quickly write down all this here. So I'm going to go fast here because there is nothing new here. Unlike the exponential function, the transformation formula is a little bit different, but this one, look at this, they match perfectly. Right? So we are still talking about 6 transformations here. So let's talk about A. Vertical stretch factor above the x-axis. Next, so there are 2 things here. And if A is negative, that means it is reflected over x-axis. So that means you flip that upside down. Then the b here, not this b, but this b inside the function. Okay, so b is the horizontal stretch factor above the y-axis. And again, that's a negative value attached to that. If b is negative, that means it is horizontal reflection. So reflected over y-axis. And then h and k, you all know that. Horizontal translation, vertical translation. So I'll just quickly write them down here. So we have 1, 2, 3, 4 transformation, and then 2 more. 1 for h, 1 for k. So for h, there's horizontal translation, and then when it is greater than 0, that means you move it to the right hand side. And when it is less than 0, so that means negative, then you move it to the left hand side. Last but not the least, the k, it is vertical translation So if k is positive, so that means it is moving up. And of course, when k is negative, less than 0, that means it's moving down. And remember the order, starting from left to right. Always do it this way. And of course, you all know what I'm going to say, the mapping notation. Mapping notation. Same thing here. And once again, this is the same as the one that you saw in the transformation unit. And the formula is not on the formula sheet. So if you have original coordinate x and y, after whatever transformation, you can write that as 1 over b for the x value plus h, and then times the y value by a, and then plus k. So this is once again super important. Okay, so that's not too much notes to talk about because it is the same old, except this time the function is logarithm instead of something else. So have a look, state the transformations from this. So what has happened going from here to here? What are the transformations? I hope you don't tell me that this new graph here on this new function has moved 6 units. Well, because you have 2 in front of x. Remember, we always want x to be 1. So before I work out this example, let me just write down the general formula again. Y equals to a times f, and the function, this time logarithm. So b, take that outside, so that x is just by itself and has 1, and then this. So if you look at this, we need to take out the 2, okay, or factor out the 2. So it becomes negative log base 2, and then take the 2 out. So that means divide everything by 2. Divide this by 2, that gives you x. That's good because we now have just 1 x, and then plus 3. If you want to argue with me saying that, Cheng, there should be horizontal translation of 6 units, you can plot this. You will see that actually the horizontal translation is 3 units, not 6. Anyway, so now here we go. We have everything here, so that should be obvious for us to figure out what were the transformations. So if you look at this, that's a negative, so that means we have a vertical refraction. So vertical refraction over the x-axis. Okay, that's one thing. What else? The b value is 2. So that means we have a horizontal stretch. By a factor of not 2, flip that, 1/2. So that means your graph is half as wide as before, or half narrower. Okay, one more thing is you take into account the 3. So 3 means in this case it is inside the function, so therefore it is horizontal translation, and because it is positive, you flip the sign. That means it is negative, so that means to the left. So to the left, and by how much? 3 units. And here we go. All right, let's look at B. Same thing, if you compare this to that, you will find that x is not 1, x is half of x. So we need to take out the 1/2. So let's rewrite that. 3 times log base 2, take out the 1/2. So that means you divide this by 1/2. Okay, then that gives you x minus divide this by 1/2. That gives you 2. If you want to double check your work, do this. 1/2 times x gives you half an x, minus 1/2 times 2 gives you 1, right? And then minus 7. Now have a quick look. Compare this to that. Okay, and then this, and then this here and that. So hopefully everything is obvious to you. So let's look at the transformation. Again, always starting from the left hand side. So that means here we have a vertical stretch. Vertical stretch by a factor of 3. So that means the graph is 3 times longer about the x-axis. Oh my. X-axis. Okay, next. This, my b factor is 1/2. My b is 1/2. So that means there would be a horizontal stretch by a factor of not 1/2, because you flip this by a factor of 2. That means you make it twice as wide as before. So above the y axis. I'm running out of space, so I'll just move things here. That's why I erase the answers for A before we started on B. So if you look at this, 2. So this one is horizontal translation. So horizontal translation. Flip this, so it becomes +2. So that means to the right by 2 units. Last but not the least, this one outside the function, vertical. So this is the vertical translation. And if you look at this, negative, you don't have to do anything for the vertical stuff. So negative means down by 7 units. 7 units. If you want, or if you're a visual type person like me, then grab this, then you'll see all these transformations. Alright? So this one we can simply graph that, but if you're wondering what kind of transformation we have with respect to what, then you may want to jot down this y equals to 3x. You don't really have to know this. Sorry, that's wrong. I don't know what I'm talking about here. So if you look at this one here, the function you are looking at, I mean the original function, would be y equals to log base 3 of x, if you're wondering what kind of transformation has happened. But anyway, you don't really have to worry about this one at all. So you just need to graph this. So let's do this on your graphing calculator. Negative, so we want log base 3, so math second last one, log base 3, and then x plus 8. X plus 8. And that's it. So, graph. So if you look at this, or if you're not sure whether you think it's correct, so go to the table of values, but I hope you can see that there is a vertical asymptote here. So this would go up, but it would never touch or even cross 1, 2, 3, 4, 5, 6, 7, 8 when x is equal to -8. And then of course you can look at the table of values to find some key points. So anyway, let's quickly sketch this here. So you would have -1, 2, 3, 4, 5, 6, 7, 8. So that's an untouchable line. So let me use red here. X equals to -8. And then for a graph, it would be something like this. Sorry, it's just a sketch, so bear with me. So y equals to negative log base 3 of x plus 8. I hope this is nothing surprising to you that we have a vertical asymptote, and that in this case the vertical asymptote is -8. So that means x could never be -8 or smaller. Why? Because remember what we said, whatever inside the log cannot be 0, cannot be negative. If you check for NPV here, so check for NPV, this has to be greater than 0. It cannot even be 0, because if you don't remember, try to take the log of a 0, doesn't matter what the base is. Log base 3 of 0, that's error undefined. Just log 0, that's undefined. So that means whatever inside, in this case x plus 8, has to be greater than 0. If you solve that, -8 on each side, that means 8 has to be greater than -8. So always check for NPV to find the vertical asymptote. So in this case, x has to be greater than -8. -8. That's why you see a graph for x values greater than -8. Nothing is on here when x is -8 or less. So if you look at this, this should be straightforward for the rest of the question. Alright, so for the domain, it has to be greater than -8. So domain such that x is greater than -8. And as long as it is the case, x could be any real numbers, no big deal. And then for the range, you can go from positive infinity all the way to negative infinity. So the range of y such that y, in this case, there's really no restrictions on y. Okay, any x-intercept, so that's easy. So let's take this here, because I don't want to keep scrolling up and down all the time. Now let's talk about any x or y-intercept. So if you look at this, so for x-intercept, that means y is 0. So y is 0 equals to negative log base 3 x plus 8. And then if you move the base 3 over here and turn it into the base of the exponent, then you have 3 raised to the power 0. Or, you know what? Let's just get rid of the negative sign first, because the negative is annoying. So, in this case, if you flip it to the other side, it doesn't change anything. So move this to this side, move the 0 to the other side, we still have the same thing, except we can get rid of the negative sign. So that means we have log base 3 of x plus 8 gives you 0. And then you move the base 3 as a log for the log to this size and turn the 3 into the base of the exponent. So like this, 3 raised to the power of 0. And then left hand side, the log is gone, so that means x plus 8. Of course, you can do this by looking at your graphing calculator, find the x-intercept, y-intercept, but let's do it algebraically, because you don't come here to learn how to use your calculator. Okay, so 3 to the power of 0, that gives you 1, so x plus 8 gives you 1, and then minus 8 on each side, so 1 minus 8 gives you negative 7. So let's find the y-intercept. So for y-intercept, that means when x is 0. So y is negative log of 3, x becomes 0. So 0 plus 8. Then let's simplify this. Log base 3 of 8. Now we do need our calculator to figure out this, because 3 and 8, they are not related. So if your graphing calculator, one last time, does not have the base function, then you can, in this case, do log 3 divided by log 8. Anyway, so I'll see right down here. If you're using a newer TI model, then just simply plug this in. You should get a number which is a decimal, not a perfect decimal. So log of 8 divided by log of 3. So that would give you, so if you just round it off to your nearest hundredth, that would give you negative 1.89. Okay, if you use a graphing calculator to find the y-intercept, that will give you the same answer. Last but not the least, the asymptotes. So we do have one asymptote, which is the vertical asymptote, right? When x is equal to negative 8. So no horizontal asymptote though. So vertical asymptote is when x is equal to negative 8 right here. The untouchable line right here like this.